I'm just trying to actually open that notepad. Somehow it's not coming. It is actually saving the earlier video file. Probably because of that. Now we'll get this. All of you are able to get my voice and watch the screen. Are you screen is visible, right? The program and all that.
Yes, sir.
So this is about a recursion. One small example we have taken. But the question is, you should be able to do it for any given problem. Then only you can say that you have understood the concept of recursion or any idea for that matter. Factorial we have seen. Yes, wonderful. Let us also examine some more examples and then slowly increase our understanding. Another one, let us say, you want to find the sum of the natural numbers, right? Sum of the natural numbers, first n numbers, kind of. For this, all of you, I assume that you are familiar with iteration, right? Essentially iteration, or normally use this particular thing, or repetition. By using for loop or while loop, you are able to find the solution. That is a different thing. But we are now actually exploring how to develop recursive solutions for the same problem. Right? For the same small problem, how are you going to do that? That is the idea. So essentially, if you examine the important things are here, like there is a base case where it doesn't call itself recursively. There is another one. This normally you call it as recursive case. This particular thing you call it as recursive. So where you are calling itself recursive. So for every any other new problem that you make an attempt, there also you will find a similar kind of situation. So now, for example, what is the likely name that we want to give it to the same thing? Let us say sum. Sum itself is the thing, and the parameter may be n here as a part. So sum of n is equal to what? Always we should think of the base case. A case where the solution is easily available. Right? So it is equal to, for example, 1. If n is equal to 1. Right? This is a base case. This is the base case. If n is 1, the sum of the first one number is naturally 1. No issue. Otherwise, what? Now we'll have to establish, like whenever n is not equal to 1, or probably like here, you may call it as less than also, but only for positive numbers. Let us assume that it is going to work. And when n is less than, probably instead of calling it as 2, or less than 2 is equivalent to, it will work only up to 1. Right? Only 1 is less than 2. 2 is not less than 2. So naturally, this is the case. So when n is greater than or equal to 2, so we can find the recursive solution. So what is the expression that we are going to have it for factorial there? It is n times factorial of n minus. Whereas here, what it is? So we can say sum of n is equal to n plus, correct? That means you are adding actually n. By adding n to the sum of all the previous numbers. If you add n to sum of all the previous numbers, that is what it is, right? So you can say sum of n minus. So naturally, sum of n minus 1, if at all it works, whatever result that you get, to that if you add n, you are going to get sum of the first n natural number. Naturally, even for sum of n minus 1, again it will recursively invoke and say that it is nothing but n minus 1 plus sum of n minus 2. And so on. It will continuously call itself with a number 1 less than the previous number. And slowly it is moving towards 1. And whenever it reaches, the parameter reaches equal to 1, then it stops calling recursively. And then you will get back all the results back. Right? So this is the case otherwise. And this normally we can consider this as a recursive. Now we have to convert this into a small proof. It is straightforward. As all of you know it, it is a public method and a static method because you want to invoke through the class. It also returns an integer value. Name of the method is sum. Parameter it requires is integer parameter. And then curly brace. Right. Here, if base case, always. If n is less than 2, whenever it is a base case, straight away return 1. Return. Otherwise, return n plus sum of the previous n minus 1 natural. That's it. Right? It's a very simple method. Now to test it, we can copy this and then copy it into recurse. Here already we have these things. Right. And all this. So into the same class now, if you examine here, public class name. So a class can contain any number of methods and any number of attributes. And in this case, it will happen. You are having 2 static methods and 1 static main in order to test. Right? So this is all there. Now what are we going to do? We will find the factorial. We will also find the sum of the first n natural numbers for the same number, probably, just to verify whether it's working properly or not. Right? So we can say. So you are basically copying the same thing. And then r is equal to, you just simply invoke sum of. And after that, here it's not factorial, it's sum of first n numbers, right? First n numbers. natural is followed by percentage d n comma r. It's the new r that is there within that, right? So and save. After that, we'll have to go into this. Then compile by using Java. So after doing this, you want to run this. Java recursion followed by 5 and 6. Factorial of 5 is 120. Sum of first 5 numbers is what? Sum of first 10 natural numbers is n into n plus 1 by 2. 5 into 6 by 2, 15. Similarly, 6 into 7 by 2 is 21. So like this, you'll have to verify whether it's working properly or not. So any questions so far? Like, are you following, all of you? So any questions or any issues there?
So,
I'm not looking at chart actually. Right, no problem. Are you following? Is the speed okay?
yes, sir.
All right. Then let us actually examine some more recursive problems and then see whether we can solve them or not. Right. So let us go back to this. So whenever it is recursion, what are we doing? We are actually trying to understand what that solution is. What is the problem and how can you express that using this particular notation? We are not directly going into program. This style of expression. Once there is clarity in this, then writing program is straightforward. There is no issue at all. Now we will take up third problem, which is going to be the sum of the first n digits. Sum of the digits. Sum of the digits of a number. Sum of the digits of a number. This is what we would like to find. And that too we want to develop by using a recursive principle. So for example, the corresponding name can be sum of the digits, right? So we will say sum d or some digits, either way. Sum of the digits. So we'll call it as digit. Some digit. This is the name of the what it is, the method. And to this, you will pass on n. And how are you going to express it? But before that, probably what it is, let us understand first. What are we trying to understand? If the number happens to be 1, 2, 5, 6, then the answer what we are expecting from this method is 1 plus 2 plus 5 plus 6, which happens to be equal to 3 plus 5, 8 plus 6, 14. So this is the answer what we are expecting in case you invoke this. If the number happens to be, let us say, 780, right, then what we expect is 7 plus 8 plus 0, which is going to be equal to. This is what we are expecting, right? And how are you going to solve this? How do you express this particular thing? Some digit of n equal to. And for this problem, essentially, you should think of recursion. Some digit of 1, 2, 5, 6 is nothing but actually, if you look at it. Is there any way by which 1256 can be separated into two, whereby 125 becomes a part of it, 6 becomes another part, right? From the given number 1256, can we separate 1 to 5 and 6 separate? For that, do we have any mathematical operation? Right? So 1, 2, 5, 6, whenever you divide with 2, divide with 10, you get 125. And when you perform mod operation on 1, 2, 5, 6 mod 10, you get 6. So you have mechanisms for splitting that. And what is happening here? So sum of the digits of 1, 2, 5, 6 is nothing but sum of the digits of 1 to 5 plus 6 to that. 6 plus sum of the digits of that. Again for that and so on. So some base case somewhere you will have to identify. So I'm just like leaving it, like giving to some time to you so that you give me the solution. About 5 to 10 minutes time. I'm just allowing you to start thinking and develop the solution on your own and share your solution. I think the problem is understood, and now it's right now 2:55. So take another 5 to 10 minutes time, and whenever you find the solution, you can discuss or you can share your screen and then show it. All that you can actually do that. I'm waiting actually for your solution. Start like maybe putting it onto your paper or maybe a computer, and then after that, once you think that your answer is correct, you share that. All right. Four వరకు రాదు.
అమ్మా నేను చెస్ట్ చేసుకుంటున్నా చెస్ట్ చేసుకుంటున్నా అందుకే మాట్లాడాను ఒక 5 నిమిషాలు నేను కూడా కాదు
Okay, I think some of you are giving in chart session. So I'm actually asking you not the program, right? So the how are you going to express in this particular manner? So still like you started at least what it is interacting. That's one good sign. But these solutions do not appear to be. So again, some of you are giving while loop. That means you are not following the class almost, right? You are just simply giving your old idea. Hmm. The two examples we have already seen. Two examples we have seen here. One is a factorial. This is what I am actually expecting. What is the base case and what is the recursive case? And like what is the solution? In what condition the base case is going to happen and what is the answer for that? And for a recursive case, how are you going to get the result? Similarly, for summation, we have seen here. Okay. For summation, we have seen. Now, for the sum of the digits, we have to now find sum of the digits of n is equal to. When is that you are going to get the answer ready? Right? When there is only a single digit, right? When there is a single digit, then the answer is no. Or when n is equal to 0 also, the answer is either, right? So a single digit also is there, still we know the answer. How do you know whether it is what is the expression for knowing whether it is a single digit or not? Whether n has got a single digit or not. The base case is when there is a single digit. So what is the expression for that and what is the answer for that? Answer, there may be some answer is there. But what is the condition for that? Single digit means 0 is a single digit, 1 is a single digit, 9 also is single, 10 has got two digits. So the condition is if n is less than 10. If n is less than 10, that means it is a single digit. The answer is readily available. N may be any one of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So when n happens to be, when n value is equal to 5, let us say, what is the sum of the digits of 5? It is 5 only. Sum of the digits of 4, it is 4. So in such a case, the answer must be n here. In such a case, the answer must be simple n. Whatever is the value of n, is the same answer that's going to be the answer for that case. Now, solution for recursive case. In the recursive case, what to do? You have to split that number now into two numbers such that the digit in the first place must be separated and the number without the first digit number should also be separated. And then we have to do some. So the digit in the first place must be added to sum of the digits of the remaining number without the first. How do you get the digit in the first place for number n? So it is straightforward. N mod 10. N mod 10 will give you the digit in the first place of that particular number. If it is 1256, 1256 mod 10 will give you 6. So that 6 must be added to sum of the digits of the remaining number, right? So you have to invoke now sum digit. Sum of the digits of which number? It is a number without the first digit. So when you say n by 10, 1256 by 10, for example, is nothing but 125. 780, for example, 780 by 10, it is going to be 78. Integer division, right? It's because of the integer division that all the fraction will be removed. So n mod 10 plus sum of the digits of n by 10. Otherwise means essentially when the number n has got more than one digit. When n has got more than one digit, recursion requires. Definitely. Recursion is required. And this is a recursive case solution. Recursive. You see, all these solutions you can give only when you analyze the problem. You think about the problem 2-3 times, what is happening, how to find, and then only slowly you are going to get used to giving such kind of solution. Any questions on this solution so far?
No, sir.
Okay, so because I know, like I know the weaknesses of like the current generation of the students, right? So that's why only whatever is required I'm focusing on. But still, you'll have to catch up. So you have to listen attentively and then like give the answers for the other problems. Give the answers for the other problems. So once this is known, then it's a matter of like what we call developing the program becomes straightforward. So we have another 10 minutes time there. It should not be an issue to complete it. So how are you going to write the code for that? It is straightforward. Public and then static method. And then it returns integer, public static int. Name of the method is sum of the digits of. It takes a parameter like n. And the condition is if n is less than 10, there is a single digit. So return n itself, whatever is the value of n, that itself. Otherwise, return what? So n mod 10 will give you the first digit plus sum of the digits of the remaining number without the first digit. And what is that? Is nothing but n by 10. You see, whatever that you are doing mechanically or manually, the same thing you have to convert it. The same thing you have to convert. So it is as simple as this. So no while loop, nothing. So we are actually talking about recursive solution, how to develop. Right? And after this now, you will have to copy this entire thing, put it into this particular thing and copy it here. Okay. Here. Just for clarity, I am leaving space, a blank line in between two methods. Right. So like this, a class can contain many methods. So some of the digits are now factorial, especially factorial. I will just limit myself because finding factorial of larger number with limited space given for integer you are not going to get it. But still, let us test it out. Nothing wrong, probably. Why to do all that? And then, how are you going to do that? So, R is equal to do n equal to that, and R equal to sum of this. So, we have to invoke or call summation of all that. Sum of the digits are there. Now, sum of not first n numbers, sum of the digits. Sum of digits. Sum of digits of so and so number. Sum of digits of so and so number is. That correct. So, right. So this is the code. I'll go into here, compile it. Then if you want to run it, Java followed by let us say 12, 25, then 120, 156. 3 numbers. See there, factorial of 11 is so and so. Sum of the first 11 numbers is 66, 11 into 12 by 9. Sum of the digits of 11, 1 plus 1 is 2, and 2 plus 5 is 7. 1 plus 2 plus 5 plus 6 is 14, right? It is happening the way it is expected. Except that for factorial, for larger numbers, as you can see, factorial of 1, 2, 5, 6, you are actually getting 0 because the integer data type cannot accommodate such large numbers. You will have to go for a different data type or different classes for that. So that is a different subject altogether. But the other two operations, it should not be any. Some of the first 1256 numbers, when you add them, you are likely to get the correct answer as a part. So in case you give 0 there as a part of it, then it works. Also, we can find it. Sum of the digits of 0 is 0. First 0 numbers is only sum of first 0 numbers is 1. So that is wrong. Right? So assuming that you are likely to give sum of the first like only positive number greater than 0. So with that assumption, you are actually okay. Otherwise, you'll have to probably change. All right. So, right. So this is how you'll have to move on. You'll have to move on. Another 3 minutes time is there. But let me actually discuss another problem to you. And with that, we will close the session for today. The next thing is something called, you are actually expected to develop a recursive method for reversing a number. And it should return that particular number, right? So that is what we are expecting. So by any chance, you say reverse of 1, 2, 5, 6. What we are expecting from this particular method is 6, 5, 2, 1. Like. So how are you going to formulate the recursive solution for this? And how do you write the corresponding program? Think about it. So I'm not going to give you the solution right away today. So probably you can also explore the internet also, nothing wrong. But at the end of it, you should understand, digest, and from there onwards, it should be a part of you. Right? So this is an assignment to you. Next class, we will talk about it. And if there are any other questions remaining, if you have any other questions, you can. Otherwise, we can close the session for today. Another important thing is that from next week onwards, you will have classes on 2 days, Wednesday and Thursday. Every Wednesday and Thursday, you will have the session from 2 o'clock on. for about similar time. And I'm going to combine the other CNIS data science students also, because we have very little time for the first mid examination. So we may have to take some more classes and all. So next week onwards, like Wednesday and Thursday, 2 o'clock onwards. So that you make a note of it. And right now, I am going to save this entire. Any other questions?